Hi everyone, in this lecture we will see a symbol, structure, operation and characteristics of power diode in comparison with the signal diode. We will see the basics of power diode. What is power diode? A power diode is a semiconductor device which are generally used in rectifier circuit to rectify a large value of current. This type of diode has a bigger PN junction area compared with the conventional diode, so it can be used in rectifying a greater value of voltage and current, such as hundreds of amperes and thousands of kilovolts. A normal diode have the same amount of doping level in both P and N portions, whereas in power diode, the one side is highly doped and other side is lightly doped. If you look at the symbol and structure of power diode, symbol of power diode is almost similar to the signal diode. It has two terminals, anode and cathode. If you look at the structure, there are three regions. The first one is a highly doped region, which is generally called as a P plus region, and second is a lightly doped region, that is N minus region, and both these regions are joined with the highly doped region, N plus region. So the region of N minus is a main factor that makes the power diode useful for high power applications. As the N minus layer is a very less doped, due to this the power diodes are generally called as a PAN diode. In PAN, the I stands for intrinsic. If you look at the difference between signal diode and power diode, signal diodes are generally used for low power applications, whereas in power diode is used for high power applications. A voltage rating of signal diodes vary from plus or minus 15 voltage. Voltage rating of power diode is kilovolt. A current rating is vary from microampere to milliampere, whereas in power diode current rating is vary from ampere to kiloampere. And power rating of signal diode is milliwatt to watt, and power diode power rating is watt to kilowatt. The construction, if you see a signal diode, it has two regions, P and N. It has two terminals, anode and cathode. Whereas in power diode, the structure has three regions, P region, N minus region and N plus region. And also it has two terminals, anode and cathode. See the operation and characteristics of signal diode. When a signal diode is forward biased, it means that the positive side of the voltage is connected to the anode and negative side of the voltage is connected to the cathode. So during forward bias, it reduces the potential barrier for the electron flow across the junction, so which permits more amount of current to pass through the diode. Coming to the reverse bias, when the signal diode is reverse biased, it means that the voltage applied to the diode is in opposite direction, which means a negative side of the voltage is connected to the anode and positive side of the voltage is connected to the cathode. So during reverse biased condition, it increases the potential barrier, making it difficult for the electron to flow through the diode. If you look at the VA characteristics of signal diode, the biasing condition, generally the signal diode can handle a high voltage and current. In germanium type of PN junction diode, the barrier voltage or a knee voltage ranges from 0.2 to 0.3. For a silicon type of diode, the knee voltage ranges from 0.6 to 0.7. So the maximum current allowed by these diodes is up to 100 milliampere. If you look at the waveform, in this forward biased region, a signal diode does not conduct until a fixed range of voltage is applied. So when the level of voltage applied is across the barrier voltage, then the diode PN junction will allow the current to flow through it. So the main relationship between the voltage and current is nonlinear, or we can call it as exponential. So which we could see in this forward biased condition. In the forward biased region, the flow of current will increases rapidly when the voltage increases a little. Now coming to the reverse biased condition, the signal diode is connected in a reverse biased. You could see a small amount of current will exist because of the minority charge carriers crossing the depletion region is called as a leakage current, or you can call it as a reverse saturation current. If the reverse bias voltage which is applied is extremely high, then the minority charge carriers will get a sufficient amount of energy to collide and split up the covalent bond to produce the electron hole pair. So this phenomenon you can call it as a breakdown. So if you look at the highest reverse voltage that is given to the signal diode before it is getting breakdown, then this state can be referred as a peak inverse voltage or a peak reverse voltage. The VA characteristic of power diode is almost similar to the signal diode. So if you look at the forward biased condition, when we increase the applied forward voltage, the forward current also increases linearly, which is shown in the yellow line. In forward biased condition, when the anode is positive with respect to cathode, the forward current will increases linearly with an increasing in the forward voltage. In reverse biased condition, when the cathode is positive with respect to anode, the diode does not conduct and the diode then experiences a small current flows in the reverse direction. So this current we can generally call it as a reverse leakage current or a reverse saturation current. So this reverse saturation current is flow due to the moment of minority charge carriers. If the reverse applied voltage we continuously increase after a certain reverse applied voltage, then the current flow through the device and the depletion region will get destroyed. So the reverse voltage is also called as a reverse breakdown voltage. So this reverse breakdown voltage is keep on increases. As a result, a reverse current also increases. The reverse current flows through the diode also increases. So the large reverse current will definitely destroy the diode. So the diode is designed to dissipate such a high amount of heat.